All right, one little bonus to add on here is that I went ahead and actually graphed the composition. So we found that f of g of x was equal to this square root here. And what I did using my knowledge of transformations is I factored out the 3. So I have f of g of x is equal to the square root of 3 times x minus 5/3 if you factor out the 3. We can check to see if we factored correctly by distributing the 3. 3 times x is 3x, and 3 times the negative 5/3 is negative 5. So I factored that correctly. And now looking at this, I can see that this is a shift to the right by 5/3. So here's 1, 2, 3, 4, 5/3. And there's also a horizontal compression going on, a horizontal dilation of 1/3 because of this 3 here. It's actually the reciprocal of 3, so it's 1/3. So this graph here, this regular square root graph, is moved to the right from the origin by 5/3, and it's also smushed in here by a factor of 1/3. So I actually get something that looks like this. It's pretty neat. And in fact, we can see that the domain of this is all real numbers from 5/3 inclusive through infinity. So let's go ahead and just play around with one more thing here. Let's go ahead and figure out what f of g of 3 is. So I'm going to do it the long way and I'm going to do it the short way. So we're now going to figure out what f of g of 3 is. First of all, is 3 in the domain of the composition? It is, so I should be able to do this. Okay, so first I'm going to figure out what g of 3 is by going to 3 and going over to the g function. It's a little bit hard to tell from my graph, but if I go up from 3 and hit this dot, this is going to be 9. I know that for sure because if I plug in 3 here, I get 3 times 3, which is 9. So g of 3 is 9. Okay, now I'm going to take 9 and I'm going to plug that in. Oh shoot, this is going to be, okay, this is okay, this is okay. I'm going to plug 9 in to my f function. And my f function is this red one here. So there's 6. Here's 7, 8, 9. And when I plug 9 in, what my output is 2. So my final answer is 2. I can double check that with the equation. When I plug 9 into my equation here, 9 minus 5 is 4, the square root of which is 2. So f of g of 3 is equal to 2. Now, that was kind of the long way, but now that I actually have a graph of f of g of x sitting right here, and instead of going that long way, I can actually just plug 3 into my graph. Here I go, 1, 2, 3. When I go up, I see that the output is 2. Very nice. Now lastly, let's say I wanted to go ahead and pick something that wasn't in the domain. 1 is not in the domain of this composite function. So let's try it anyway, see what happens. Let's try to figure out, where am I going to write this? Can you guys see here? Yeah. So lastly, I'm going to figure out what is f of g of 1. I'm going to try to figure this out, but I'm anticipating I'm going to run into a problem. Let's see what happens. Well, first I'll figure out what g of 1 is. And 1 is in the domain of g, so that's not going to be too much of a problem. I'm going to plug in 1. I'm going to go up, and the output will be 2. So g of 1 is 2. So now I need to figure out what f of 2 is. Let's go ahead into my red f function and figure out what f of 2 is. Wait a minute. 2, this red graph here, I can't plug 2 into it. I never intersect the red graph way over here. As we can see here, 2 is not greater than or equal to 5. It's not in that domain. 2 minus 5 is negative 3. And if I take the square root of a negative number, I get something imaginary, nothing real at all. So this is going to end up being a problem. We can't do this because 2 is not in the domain of f, because 1 is not in the domain of the composite function. Hope that helps.